Hello everyone, I am Abhijit Burathoki and welcome to my YouTube channel. Today we will be discussing about one of the coolest and one of my favorite tricks to find the day of the week in any given date. So for that, now first we will look upon into the trick, and then in the successive video we will discuss about the tricks. We will discuss about the theory that's behind the trick. So first of all, let us suppose that we are given year and then month and then day of the month, right? Then our first step will be we will perform modular division. And by modular division I mean to say that if I am modular dividing A by B, then A mod B will give me the remainder. When A is divided by B, it will give me remainder R. So let's suppose we have 12 mod 7. So when 12 is divided by 7, then 7 times 1 is 7. The quotient is 1, but if you know the remainder is 12 minus 7 gives us 5. So the answer this modular division will give us is 5, which is the remainder when 12 is divided by 7. So first of all, we are going to perform modular division in day by 7. Day mod 7 will give us a remainder, and we will let this be A, our first code for the day of the month. Then we move on to the month, and for month we need to see if the year that we are going to talk about is a general year or leap year. So first of all, if we have to check this by integer dividing by 4, or we can do the similar modular divide by 7. And if year modular divide by not 7 but 4, because if we have to check whether a given year is a leap year or general year, then we need to find out if it is exactly divisible by 4. Exactly divisible means that if year is modular modular divided by 4, then if it can have either 0 as remainder or 1, 2, 3 as remainder. So if the answer is 0, then the given year is leap year, and if it's not, then the year is general year. That's it. So first we perform year modulus 4, then this will give us either 0 or 1, 2, 3. If it's 0, then we are sure that that year is leap year, and if it's not 0 or non-zero or either of 1, 2, 3, then it's a general year. Now we assign the code for the type of year here. Type of year code. If it's a general year, then we assign the code -1. If it's a leap year, we assign the code 0. This is for type of year. And then we move into the year. For that I will be discussing later, but we just found out if the year is general or if the year is leap year. Then we will have respective codes for each month of that year. If it's a general year, we have separate codes, and if it's a leap year, we have separate codes for any month. So suppose we have we have 12 months in a year, so let us give the their respective numbers as months: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be our January, February, March, April, May, June, and so on to December. So for general year, the code is 1440225036146. And for leap year the code is very similar to it, but if we for memorizing this code for general year, we have to divide this 12 set of codes into 4 groups of 3, right? This 144 is 12 squared, this 025 is 5 squared, this 036 is 6 squared, and 146 is 12 squared plus 2. So if we divide total 12 codes into the group of 3 in each, then memorizing the code becomes easier. This is 12 squared, this is 5 squared, and this is 6 squared, this is 12 squared plus 2. And for leap year, only the first group changes and the other groups are very same, or as it is in general year. So for first group, the code for leap year is 034, and then the same code goes on 025, 036, 146. And for that we have to memorize that for leap year the first set of group is very specific, so we need to memorize the specific code for leap year. Then other groups are same as the general year, same as general year. So now if our month is January and if the year is general, then the code will be 1, but if it's a leap year then the code will be 0. Similarly, if it's October, then if it's a general year then the code will be 1, and if it's a leap year then code will be here also code will be 1. So another code we will get from here, let this code be B for the type of year, because for finding the code of the month we have to first look at the type of year code. First we divided modular divided by 7 and this gave us A, then we set for the type of year gave us B, and then the type of for the code of month we have, let's suppose we have C. Then now finally we come for year. Now first step is we have to subtract 1 from year. We often forget this in practical aspects, so be very careful in this step. Subtract 1 from year, because if we do not subtract 1 from year then the answer will be completely out of the world. So after that we have to break this number, whatever the number here is, into some leap century year. Leap century year plus some century year plus remaining years. Remaining years may contain only 1 digit or up to 2 digits. So what do we mean by leap century year? Leap century year here means any lower 400 m number, that is this number should be a little bit lower than this number year minus 1, and also that number be the that number be shows that it should be exactly divisible by 400, such as 400, 800, 1200, 1600, 2000 and so on. We break the year minus 1 into leap century year, which are in this fashion. We break them into the the very near lower one, and then we completely ignore this because we have no value of this in our code, because as we will see in the theory that this leap century year has code 0, so adding 0 means nothing, so we ignore this. And then we come to century year. Since we have converted, broken this year minus 1 apart into the some 400 em, then we can have only 3 century years here. Either it will be 100 or 200 or 300. So we have specific codes here for century years. If it's 100, then the code is 5. If it's a 200, then the code is 3, and if it's 300, then code is 1. It's easy to memorize here also, because lowest one is 100, so it gets the biggest code 5. Middle one is 200, it gets the medium sized code 3, and the highest number is 300, and so it gets the lowest. The relation is opposite, we can see. So 5 for 100, 3 for 200, and 1 for 300. So this code is for century year, and let's say A, B, C. Now this code may be D. And now we have remaining years, and for giving the code to remaining years, we need to find out how many leap years are in the remaining years. And for that, we have to perform a division, which is known as integer division. And in integer division, I want to emphasize, in integer division, we are left with the number that is integer in the quotient. Suppose we divide it by 7 divided by 4. Suppose we perform integer divide where 7 is divided by 4, then in actual 7 divided by 4 gives us 4 and then 7 5 1.75. But this integer division will give us only the integer part, which here is 1. That is integer division. We completely ignore the decimal, whatever the numbers there are after this decimal point. So we will perform, if remaining years is small r, then we perform integer division by 4, and whatever will be the result will be, let's say, I, where I is the number of leap years. This I will be the number of leap years. What do we do here? We take the remaining years, then perform integer division by 4, and this will give us an integer I from 0 to any number. Then that also has limit. We will talk about that in theory. Then this I is the number of leap years. Then we want to have the last code for the remaining years, and that will be equal to I plus R, that is number of leap years added to the remaining years. The last code will be our E. Now finally we have all the codes necessary for finding the day of the week. We have A here and day, B for the type of year, C for the month, D for the century year, and E for the remaining years, right? And there was 0 for the leap century year, but since 0 has no effect on this, we ignore that for now. Then the next step, then we are about in the final steps of finding the day of the week. We add the code A, the code B, C, D, and E, and whatever the sum we will have, let's assign that to S, and the final will be, we will perform again modular division, S mod by 7, and whatever the remainder we will have will tell us the day of the week. And this W can have value from 0 to 6. If it's a 0, then if it's Sunday. If it's 1, Monday. 2 for Tuesday. 3 for Wednesday. 4 for Thursday. 5 for Friday, and 6 for Saturday. So whatever the number we will have, if it's a 0, then we know that the day is Sunday, and if it's 1, Monday to Tuesday, and so on up to 6 as Saturday. So this is the trick. Now in the next video we will perform some calculations, and we will be confident about this trick. By using that this trick, we will be confirmed, or we will have confidence about finding the day of the week. So the main aspect of this trick is we have to practice it for a number of times before being very fluent in it. So we may forget something somewhere. Suppose we may forget that day mode. Sometimes we may perform for leap years, we know we are performing day mode by year mode by 4. So we may be confused with 4 and 7. Sometimes we may write 4 here, sometimes we may write 7 here. So that will give us the wrong answers. So we need to be very precise on the steps. First, day mode 7, and this will give us A. Then we'll look for the code of the month, and for general years we have codes 144, 025, 036, 146, and for leap year the code is same, but for only different for the first group, which is 034, and this will give us the code C. And before that, we need to find out the code B by looking at the type of year. And for finding the type of year, we need to perform year mode by 4, or we can say that if this year is exactly divisible by 4, if it's exactly divisible, then it's a leap year, without going into the modular division. If this year is exactly divisible by 4, then if it's a leap year, and if not, then it's a general year. And -1 for the general year, 0 for the leap year. Then for the code of year, we first subtract 1 from the year. We often forget this step, and we directly perform the lower steps directly into year. So that will give us again the wrong answer. So first we need to subtract 1 from the year, then break it apart into leap century year plus century year plus remaining years. We can completely ignore the leap century year. Then for century years we can have either 100, 200, or 300, and for 100 the code is 5, for 200 3, and for 300 it's 1, and the code is assigned as D. Then for the remaining years we need to first perform integer division. And if we are not familiar with integer division, let's just say we divide r by 4, and whatever the number comes in the left hand side of the decimal point, we keep that as I, that is number of leap years. And for the code E, we add the number of leap years to the remaining years, and this will give us the code E. And the next step is we add all the codes from A to E, and then this will give us a sum S, and at last we perform modular division by 7, and that will give us W. And if W is 0, then it's a Sunday, and so on up to 6. If it's a 6, then it's a Saturday. So for the theory behind the trick and for applications, please continue to next video. So if you like my video, please give thumbs up, and if you haven't subscribed it, then please subscribe my channel and press the bell icon also for getting updated notifications, and keep watching. Thank you so much.